Okay, today class we're going to talk about graphing these polynomial functions, which will kind of continue what we did yesterday. First thing that we talked about yesterday is that each zero is an x-intercept. Okay, so the example I have is that if I have a function that's x plus 2 and x minus 3, then we have the zeros, or x-intercepts I should say, and I talked about this yesterday, negative 2 comma 0 and 3 comma 0. And also remember that even zeros bounce / touch, whatever you want to call it, and odd ones cross. Okay, so let's look at some common patterns for different powers of functions. X at y equals x, you guys all know, is the line that looks like this. Whereas y equals x squared, so the 0 is at 0, 0, and it crosses. Y equals x squared, though, now it's a 0 at x, at 0, but it bounces, and that's why you get that parabola, right? It doesn't cross through. For cubic, the 0 is again at 0, but since it's a third power, it crosses, and it kind of looks like this. And then finally, for a fourth power, a quartic, the 0's here, and it bounces again. Now, you can get fourth power ones looking like this, you know, something like that. But basically, it kind of looks like a parabola or that. Now, if you notice, we're going to talk a little bit about end behavior here. So again, if for end behavior, it's what the graph's doing at the ends. So if you go all the way to the left or all the way to the right. If the lead coefficient is positive, and we have an even function, so that would be like this one right here, x squared. Notice how both arrows point up, so we always end up with positive infinity for our end behavior. However, if it's an odd function like a line and it's positive, it ends up going up, but if you go off to the left, it'll go down forever. That's different for if the lead coefficient is negative. For an even function, you guys should know this, when you have a negative quadratic, it flips it over the x-axis. So that means that if it's even and negative, that means both end behaviors, both the left and right end behavior are going to be negative, infinity. And for an odd function, it just reverses the line. Think of a slope of a line going, think of a line with a negative slope. It would end going down, and to the left it would be going up. So that's our end behaviors. We're going to do that when we talk about this. So let's sketch this graph. So let's get our information first. First things I know, the x-intercepts are at 3, 0, and because there's no power, it's a power of 1, it crosses there. At negative 4, 0, it bounces. It's a third power, degree 3, and positive, because it's a positive coefficient. And then the last thing you can do, it's very easy to get the y-intercept. You just plug a 0 in for everything. So 0 here is 4 squared, 16 times negative 6. You get negative 96. So I actually should write that 0 comma negative 96. 0 comma negative 96. Okay, that's really all I need to know. Because the degree is 3 and positive, we know it's going to look kind of like this, the end behavior. So let's try to put all this together. I'm at 3, 1, 2, 3, negative 4, 1, 2, 3, 4. We can exaggerate the y-intercept. Let me just put it down there. So we know that it crosses through here and bounces here. And we also know that it ends up going up because of the end behavior. So we can kind of just sketch it. We know it probably turns around somewhere in here. but then it just touches there. Remember, it doesn't cross at that and bounces back down. And sure enough, this is a third power graph. Okay? So this is kind of just a guess, an estimate. I'm really looking for this, and then it ends, and then it kind of looks like a third degree graph. All right, let's try another one. All right, I notice that it's a negative lead coefficient. I notice that I have an x-intercept at -2, 0, and it crosses. I have 1, 0, crosses. And then I have this. I don't know what that is, so I'm going to solve it. X squared plus 1 equals 0. X squared equals -1. These are not real, so not intercepts. Now, the degree, though, is still part of this. So we have an x and x and then an x squared. So we're going to have a degree of 4. And it's a negative lead coefficient. So whenever it's an even degree, think of the behavior. It's going to be like a negative quadratic, so on the ends it'll be pointing down. The end behavior function is pretty much just what you would have, the biggest piece. That'd be y equals -x to the 4th. Did I forget that on the other side? Yes, I did. Sorry. Let me go back real quick. Up here, the end behavior function is what is the highest degree, and if you multiply everything out, here it would just be 2x cubed. Or actually, we just want, never mind, we just want the power. We don't need the lead coefficient. So I'd say y equals x cubed. That's the highest. That's kind of what it looks like at the ends. Here, it's -x to the 4th. So let's graph this. Again, oh, and I could have found the y-intercept. When you put a 0 in for everything, you get, what do you get? 2, -1, -2 times -10, -20. No, +20, sorry. So you get like something up there. All right, so we know at -2, it crosses, and at 1 it crosses. So it looks something like this, probably. And sure enough, that is going down in both directions. If you're not sure, I want you to try to graph these first and then maybe use your calculator to see what it looks like. But that would be what I was looking for that one. Now we're going to go backwards. Find the equation of the function. So a few things I know. That I have the point -2, 0, and that it bounces. I have the point 1, 0, and it crosses. And I have the point 1, 2, 3, 4, 5, 0, and it crosses. I also have the y-intercept of 1, 2, 0, -3. I'll use that to find my a value. We know that the degree then is 4, because this is a double degree, and then 1, 1, so there's 4. And then we know a is negative. So I'm going to write my equation out. We know that in factored form it's a times the zeros. So the first 0 is x plus 2 because it's the opposite sign, and I'm going to put a square there because it bounces there. Remember, that tells you the multiplicity is 2. These are multiplicities of 1. So that means that this one is x minus 1. Remember, it's the opposite. And this one is x minus 5. So we're almost done. We came up with a base model. Now we have to use the point 0, -3 to find a. So when f of x is -3, x is 0. So we get 2 squared is 4 times -1 times -5. That's positive 20. So we get -3 equals positive 20a. So a is equal to -3/20. So we did get an a value that's negative, which is what we wanted. So our final factored answer is -3/20. x plus 2 quantities squared, x minus 1, and x minus 5. Okay, so again, hopefully you guys go back through this and see which piece goes with what when it bounces versus crosses, and then the end behavior. Since this is a degree of 4 and negative, it's pointing down in both directions. Good. All right. I will see you guys later.